So what was that called? Recently I joined Flashbots, the TEE. And yeah, before I started the demos, I just wanted to speed the slides because thanks to these talks here, I presented all the details. So yeah, we are currently going to show some demos on the TDX technology. So you probably are familiar with the TDX, which is part of the process, and the TDX is having some much bigger TCP. And it's because we now have not only the application, now we have the SOS, admin. Yeah, so many other processes that we're running inside the virtual machine that are not trusted. And to tackle this problem, basically, it's not a problem, but we want to have a small TCP. In that case, we are using currently which basically lets you to build your virtual machine layer by layer, just to minimize the execution base and not having any extra processing running on the side of your your application wants to run the TEE. As you can see here, Shay already presented what we are doing now. For example, this is one of the use cases. We are putting the R builder inside TDX, and you have just seen like what the benefits of doing so. So we will show like shortly the demo. But I also wanted to talk about a little bit of the chain of trust. So now we have the TDX VM, and currently if you have three approaches to do it. Either you basically deploy it on the cloud providers such as Azure or GCP. And in the case of Azure, you get some PROS, which is execution assurance that is running on your premise. Also like June distribution, where they are provided. And the typical cloud provider benefits. However, you have some cons, which is you are adding an extra layer of trust here because there is the HCL, which is basically running your VM and so on. So it's part of the attestation because now the attestation is using the BTPM. And then, of course, last but not least, in the end of chain trust, when you are doing the provisioning, provisioning certification. The second approach would be the bare metal, like an OVH or PNAP. You can rent a TDX machine and do it on your own. And this way, basically, you get the pros of having full control, so no extra proprietary firmware. It's probably cheaper than what we do. And you're using this hardware such as providers for example. The cons, however, currently not the CEDX, so with the data center execution assurance, where it's been run. However, this can be worked on. Of course, and the geo distribution is actually difficult. And the third approach, Andrew already talked about this. The open trust hardware has its benefits. We'll talk about this probably later, much more in detail. So we'll see it. This is the TDX implementation station. Let's skip it for now because just showing that this is a general side chain trust, and it also leverages TDX primitives supporting enclave. We probably talked too much about this already, so skipping it. This is a snippet of a TD code that we generated on the bare metal, and then we parsed it. As you can see here, we have here some important fields, which are the MITD, the measurement of the TD module that is running. So the firmware we just signed by Intel, and you have the RTMR 0, 1, and 2, and 3. Those are representing the hash of the unified kernel, like the kernel image is running the interim FS of the RAMFS of your image, all the lines in it. And the RTMR 2 is basically the CMD line when you put your image inside the memory. For now, we will see some kind of attestation on Azure as well, or demo. So how it works, as I said, they are using the BTPM measure boot. We were able to do the reproducible parts. This is from Constellation. So we are using the PCR 4, 9, and 11, which basically represent the same thing as I just mentioned, the unified kernel cache that we are putting on Azure, and Initron S, and Zero. So without further ado, let's do some demos. Woo! Let's see. What I have to.
Could you increase the font?
Yes. So for now, let's do the something font. What? Yeah. No, I can try to. So now we can have a stage with running sheets, and I can show you now that both of them are running right, or let us take here. The processes that are running, it's actually when you see when it starts up, it's actually running exactly only the applications that we started with. So basically, it's only REST and our builder, and all of those processes are basically the keywords that are being executed inside the REST and our builder. So basically, this is very cool because now you have literally an operating system running only your binaries, and we are building it in a reproducible way that's such that wherever you build this image, it's generating the same measurement. So you can use those measurements and do that at the station. You can make sure that on the cloud that's being running is actually exactly the one that you're built, or even either your code to the thing that you can do measurements and so on. So basically you can literally verify this. So here I can show you, for example, the output of REST, which is currently running. So yeah, we already have it synced since a week now, and so we also ran the Arbiter, the public one, which we can also see in our plate. Of course, in the final deployment, you wouldn't have the SSH access. So this is just for demo purposes. But as you can see here, our Arbiter is currently running and building blocks. But we didn't open it here. This is here just like the environment. We are not really like sending bundles or anything to it, just to show like it's submitting bits, it's getting some transactions from the mempool and trying to build blocks and decode it. But yeah, this is just like just a snippet of like how it's been working. So we have the working MVP with the probable address, and let's do some attestation. So we have the measurements. Let's see. Hopefully it will work. So, let's start to new Wanda client. So here let's do the first proxy. First proxy. Let me show you. Yes. So, I can show it here.
For the record, the measurement was generated from the image. I was.
Yeah.
You can build the image to get the same sheet.
Anyway, so let me show you the measurements, how they are generated. And it looks like something like this. So as I mentioned earlier in the slides, you can see here the PCR11 measurement and the PCR4 measurement and the PCR9. These are every time you rebuild the image with new stuff, for example, they change. But if you are rebuilding the same image, they are always identical, which just makes it more credible in order to do that. So now let's run the.
This is TDX, this is not TDX.
Yeah, this is PM approach of Azure. And I showed you the TD quotes of that bare metal, how it would look like. And we are also working on a way inside Yocto when you deploy it on bare metal, we also do the way of Intel. This is work in progress. Right. Yeah. So now we can curl it. So we can curl this reverse proxy with this measurement that we are expecting. I just showed you for the image, and As you can see here on the left side, basically it's received the like request to do that attestation. It's sent it to Azure, and Azure looked into the measurement and sent it back. This is valid. So in this way, it's basically Azure in this case is seeing the measurement that is loaded in the VTPM and then compares them and sees if they are identical with the one that's being deployed, and then gives you like it's valid like by their sign, it's the sign validation function. And this is also like gives you like the CEA. So basically, it's you know that it's been deployed on Azure premises. Yeah. So I think this is one of the examples with our builders running on Azure. I can show you a snippet of the experimental, but please bear in mind it's still work in progress. So this is a bare metal machine, and we can show you here. We are running also REST inside the Moe, inside the TD machine, and in this case here, the fun part is we have access actually to the TD guest module, which basically would allow you to generate this thing. So I can show you TDX guest. So this is there, and we can also see, similarly to the one deployed on Azure, but on bare metal, it's also like very minimal virtual machine running only applications and builder, and we can see here also. So now you can see how the rest is all still currently syncing. So yeah, this is the rest currently syncing at the stage. So 87%, but yeah, so it's also like in this approach it's also working on the experimental. So yeah, please stay tuned. If you have any questions, should I?
Quick question. In the Azure version, what exactly was the signature for those measurements? Or is the signature added on top of the measurements JSON? What exactly does the Azure module check when you send the information?
So, to my understanding, how Azure is doing it is basically when you do the attestation, you are trusting this HC. So they have this HCL hardware multilayer, which basically it's run on top. You can somehow think of it as like a little OS, which runs before your VM, and then it boots up your VM and then loads its embedded root inside the VTPM that is assigned to your. So this makes it like you're trusting here the VTPM in this case that it's loading the right measurements of your image into this exact PCR instance, and then so everything then is signed by the signature of Azure. In this case, we compare it to this firmware. Yes. So in Yocto now we have everything open source, so we can also check it. We recommend everyone to help us if they want. But yeah, everything is built in Yocto, and we are providing Docker ways to do the building inside Docker. So basically, if you do this building on any machines, we verify those measurements. I mean, listen, you cannot be 100% sure because there are some artifacts, for example, in the R-builder, some dependencies in REST, where they have some access to specific output methods. But once you solve all these minimal issues, then it's 100% useful.
But there's a guy who's here like Dave.
Yeah. Dave? Oh, I mean, we have a section.
Anyways, you should talk to him because I think.
Yeah, we will have a separate conversation and later on this section because it's a much different
I feel like why would that really use it? A lot of people think that Docker should it's big thing.
It's big. It's not Docker.
Okay.
Docker is just like the OS that is running Bitbake. but running good. So Yocto is doing the reproducible not so Yocto is and Yocto does the building where you specify for each binary that you are baking into this virtual machine where it hashes and where it builds that you expect inside this virtual machine. So you are specifying exact versions of the firm application that's are being built inside. So that's why it's reproducible. You are specifying for each binary inside of the correct version.
Okay, so one more question, and then we have one and then we have our another keynote. So maybe.
Yes. So yes. So we are not measuring the application separately. We are putting the application in the interface. So we are putting the image and putting the binaries being built inside the initial RAM when you use the image. They are actually not directly in the RAM and not on the disk. And we all know that TDX on the disk side is not part of the measurement. And this is actually not trusted. Everything run in RAM is the trusted part. So when you put your image, putting your binary already in the initial RAM, this initial RAM is being measured. And this measurement will be considered like all the applications we put inside the initial RAM are measured. And so if you change your application in the build process, without changing any other thing, you will notice that the PCR, I think, 9 will be changing subsequently because the image interface changes.